Increasing and decreasing functions. Basically, if you're going to the right and your function goes down, it's a decreasing function. If you're going to the right and your function goes up, it's an increasing function. If you're not going up or down, then it's considered a constant function. Whenever you have a decreasing function, your derivative is negative, meaning less than zero. Whenever your function is going up, increasing, your derivative is positive. Whenever your function is constant, your derivative is zero. Because remember, your derivative is the slope of your tangent lines. Now, down below here, we have an example of a min. In this case, it's an absolute min because we're a parabola going up, and this is the farthest it ever goes down. If we were looking at our derivatives here, to the left over here, you're decreasing, so your derivative is negative. Over here, you're going up. So if you're looking at your derivatives, you can realize then that it's a valley, so it's a minimum. Here, you're increasing, so you know you're going up. Here, you're decreasing, so you know you're going down. So if you're looking at your derivatives, you're increasing and decreasing, lets you know you have a mountaintop, so it's a maximum. Here, it's an upside down parabola, so you know it's an absolute maximum. Here you're going up for your derivatives, going down, and then going up. So if you're looking at your derivatives, you can know if you have a max or a min without actually seeing your original function. Over here in the far right, you're going up, and then you're going up. It's not a mountain, it's not a valley, so it's not a max, it's not a min. When we're looking for maximums and minimums, sometimes they'll be absolute like the first two, sometimes they'll be relative. Highest point in the area or lowest point in the area, but not of the whole graph. So here we need to go ahead and find our critical points to be able to see where our derivative is increasing and decreasing. So you take your derivative, set your derivative equal to 0, because remember your critical points are where your derivative is 0 or your derivative is undefined. So now we're going to just solve this by factoring. We now have three things multiplied together to give you 0. So you got to think, okay, what causes these three things to be 0? One of the three things to be 0. The first one to be 0 when x is 0. The second one when x is 2. Third one when x is -1. You then want to go ahead and take these critical points. And remember, critical points are where your derivative is 0 or undefined. Since we have no variables in our denominator, our derivative would never be undefined. We'll take our three critical points, we'll put them on a number line. We're going to be using our first derivative test, so we're going to be testing this into our first derivative. So we need to have our number line labeled as our first derivative, f prime of x. Now we're going to take a number in each one of these points and try it. Let's try a number over here to the left of -1, say -2, and we're going to try it into our factored form of our derivative. Be negative here, negative here, negative here. When you multiply, you then get a negative. If your derivative is negative, that means you're decreasing, so you're going to be going down. Then you could try a point in between. You could try, say, -1/2. Plugging it in up here, and you would end up getting a positive. If it's positive, that means your function is going up, so I'm going to draw a line going up. So that means since this is the bottom of a valley, I would have a minimum here. Also over here, I'm going to try 1. Plug 1 into all these spots up here. And once again, I would end up getting a negative, so I'm going to put negatives on the top of my number line. Since it's negative, I'm going to draw a line going down, which means I have a mountaintop here, which means at 0 I would have a maximum. Over here, I could try a number and plug it in. I get everything to be positive, so that means I'm going up. And remember, when we're checking these numbers, we're plugging it into our derivative. Since I have a valley here, I would have a minimum. Well, how do you actually figure out the y-coordinates of your minimum. If you know your x-coordinate is this, your x-coordinate's that, and your x-coordinate's that. How do you actually figure out the y-coordinates? Well, all you have to do then is just plug those back into your original problem up here. Plugging in -1 up here into your original function to get the y-coordinate of your point, and you get 0. Plug 0 into your original function up here, and you will get 5. Plug 2 into your original function up here for all your x's to get the y-coordinate, and we end up getting -27. In this particular case, this would be your absolute min. You'll notice on each end you're going up forever, so that means it's a touchdown equation, which means this would be the absolute min, the lowest, because it's smaller than this one here. This would be your relative min. Since we go up forever on each end, we would know this would only be a relative max. So when is your function decreasing? It's when your derivative is negative. Well, that we get from our number line from -infinity to -1, from 0 to 2. When is it positive for your increasing function? Between -1 and 0, and between 2 and infinity. Here it's just saying if you have a valley when you're looking at your tangent lines, it's a min. If you have a max, or a mountain peak, it's a max. So now we'll go ahead and we'll find our extrema here. Your extrema are your maximums and your minimums. Well, once again, you got to find your derivative. So put your exponent in front, decrease your exponent by 1. Remember the chain rule times the derivative of the inside. A little bit of simplification. Your negative exponent moves down to the bottom. Then your critical points are where your derivative is 0 or undefined. Your derivative would be 0 when the top is 0. It would be undefined at what causes the bottom to be 0, and that would be plus or minus 2. You then want to take those three critical points of 0 and plus or minus 2, put them on your number line. Then once again, just like we did in the previous problem, take a number in each one of these regions. Try something like -3 over here, plugging it into your derivative. When you plug -3 in, you get a negative on the top, and you would then get a positive on the bottom, which means overall it's a negative, which means you draw a line going down because it's decreasing. Try a number in between, say -1. When you do that, you would get a negative on the top, you get a negative on the bottom, which means a negative over a negative is a positive, which means I would draw a line going up here because I'm increasing. Over here, I'd try, say, 1. Well, that's going to make my top positive, but the bottom's still going to be negative, so I'll get a negative. So I'm going to draw a line going down and do the same thing over here if I try, say, 3. And I get positive, so I'm going to draw a line going up. Bottom of a valley, so I know that's a minimum. Bottom of a valley, so I know that's a minimum. Mountaintop, so I know that's a maximum. So you got to go ahead and figure out your y-coordinates. If you're looking for the y-coordinates, you need to go ahead and plug that into your original function because you're looking for points on the graph. Plug 2 into your original, and you get 0. Plug -2 into your original, you get 0. Plug 0 into your original, you get the cube root of 16, which if you wanted, you could write as 2 cube root of 2. So you're looking for the extrema. These are your extremas here. In this case, this one here would be a relative max. These would be both your absolute mins. Also, if you're looking to see where you're decreasing, that's when your derivative is negative. If you're looking to see where you are increasing, that would be when your derivative is positive. Once again, your critical points are where your derivative is 0 or undefined, and those are the numbers you're going to want to put on your number line. Also make sure you have your number line labeled as f prime of x.